So this was our last slide for our video 2 of chapter 9. Moving to the next topic. This is your differential equations with variable separable. So we have to solve here the given differential equation in which the variables can be easily separated, and then we have to find the value of y, that is the solution of that equation. Suppose it is written here, find the general solution of the differential equation dy by dx is equal to x plus 1 upon 2 minus y, where y is not equal to 2. So you can easily see this denominator in the right hand side is totally with y and the numerator is with x. This is dy upon dx. Now taking all the y terms towards left hand side and all the terms with x on the right hand side. So we had just a kind of a cross multiplication, and then we have to find the value of y. So we'll integrate this whole equation. So putting the sign of integration both the sides, integration of 2 will be 2y and integration of y is y square upon 2. Similarly, for the integration of x is x square upon 2 plus x plus c1. We'll put the constant of integration towards only x side and not towards both the sides. And finally, taking the LCM and taking all the terms towards left hand side. And this is the general solution of the given differential equation. So basically what we have to do in exercise 9.4, we have to just separate our variables and we have to integrate it so that we can easily find the value of y. Let's see another one. This is your exercise 9.4, question number 1. We are given dy by dx is equal to 1 minus cos x upon 1 plus cos x. So the given differential equation, you can easily see there's toward right hand side only it is in the form of x. So no y is there, so we'll not take anything towards left hand side. We'll only bring from left hand side dx towards right hand side. So we had brought it here and applying the formula. This is a trigonometric formula of semi-angle where 1 minus cos x is equal to 2 sine square x upon 2 and 1 plus cos x is equal to 2 cos square x upon 2, and which we are getting tan square x upon 2. This is sec square x upon 2 minus 1. Applying the formula of trigonometry, you should always remember all the formulas of trigonometry. Then only we can do this integration or differentiation very easily. So now it is becoming sec square x upon 2 minus 1. Now taking dx towards right hand side and integrating. So we are having here integration of dy, that will be y, integration of sec square x upon 2, which is tan x upon 2 upon 1 upon 2, which will give you 2 tan x upon 2 minus x plus c. I already told you the constant will be only towards the right hand side. So maximum times you will be getting the answer in the form of y. Y is equal to something in the form of x plus c. This c is very much necessary. That is the integration constant. So this is our general solution. See another question. We'll do few questions so that you can easily complete your exercise 9.4 in your notebooks. See here, dy by dx plus y is equal to 1. Taking this y towards the right hand side, I am getting here 1 minus y, and taking this 1 minus y towards left hand side, I am getting dy upon 1 minus y is equal to dx, and integrating both the sides. See, this integration is there. Log of 1 minus y is equal to x plus log c. This is 1 minus y, and with y there is a minus 1, which will be giving me minus log 1 minus y. This log c, I am taking it to the left hand side so that both the logs can be combined, and I am getting log c into 1 minus y is equal to minus x. When we remove this log from any side, the other side becomes the power of an exponential. So this is becoming c into 1 minus y is equal to e to the power minus x. This c will be coming in the denominator, and I will be getting 1 minus y is equal to e to the power minus x upon c. So I am getting y is equal to 1 minus 1 upon c e to the power minus x. So this minus 1 upon c, I can write another integrating constant, that is a I am representing here. If you leave it like this also, there is no problem. But here I am giving them the name as a e to the power minus x. So this is the solution of this given differential equation. Let's do few more questions. Let's see, this is question number 5. A very easy question, but when you see this question, you don't know how to do it. So always you have to first think about the differential equation, that whether the variables are getting separable or not. So let us see first. So this is your differential equation, taking this all the terms with a minus sign towards right hand side, and then putting all the x terms on one side and the y terms on the other side. I am getting here dy is equal to e to the power x minus e to the power minus x upon e to the power x plus e to the power minus x dx. And integrating both the sides, I am getting here on the left hand side as y, and towards the right hand side, just see, if I take the denominator e to the power x plus e to the power minus x as t, on differentiating I am getting this, the term which is in the numerator. So this becomes dt and this is t, so it is becoming dt upon t, which will be giving me log t. So it is y is equal to log t plus c. And in place of t, I had to again substitute the value in the form of x. Do not leave the answer in the form of t. Always the answer comes in the same variables which were given in the question. So y is equal to log e to the power x plus e to the power minus x plus c, which is the required general solution of the given differential equation. So this is always in the form of y. Try to bring the answer, the final answer in the form of y, so that all the terms, remaining terms on the right hand side. Let's do another question. This is your question number 10 of this exercise. And we are having e to the power x tan y dx plus 1 minus e to the power x square y dy is equal to 0. And taking again this one term towards the other side. So I am getting here minus e to the power x tan y dx. Though this is tan y, this is x square y. I can take this tan y in the denominator and 1 minus e to the power x in the denominator on the right hand side. So I have done this. See in the next step. All the variables are separated easily. I am telling you this again and again because in the next exercise, you will not be able to separate the variables. Then we'll be using some other method. So until and unless all the variables are getting separated, we have to use this variable separable method. So see this, variables are separated now. Now to for the left hand side, if I take tan y as u, sec square y dy will become du, which will give me du upon u. See this, du upon u, which will give me log u, that is log of tan y. This is of the left hand side, the integration. Now for the right hand side, if I take 1 minus e to the power x is equal to t, I am getting minus e to the power x dx is equal to dt. See this? And in place of this, we'll substitute this dt upon t, which will give me log t, or I can say log 1 minus e to the power of x. So substituting both the integration values in the equation 1, I am getting log of tan y is equal to log of 1 minus e to the power x plus log c. Why this is log c? When all the terms are coming in the form of log, the integrating constant will also come in the form of log. And applying the properties of log, which will give me log c into 1 minus e to the power x, or I can write tan y is equal to c into 1 minus e to the power of x. Further, we cannot solve it. So this is the required answer of the given differential equation. That was question number 10. Now another question we will be doing. This is your question number 12. This is the given differential equation, x into x square minus 1 dy by dx is equal to 1. See here, now here it is given y is equal to 0 when x is equal to 2. This will not give you the general solution. This will give you the particular solution, because after finding out the answer in the term of c, we'll substitute y is equal to 0 and x is equal to 2, so that we'll get some value of c also. So let's start. Again, all the x terms towards right hand side, y terms towards the left hand side, we are getting this. And factorizing this, we are getting 1 upon x into x minus 1 upon x plus 1. And doing the integration by partial fraction. See this? Solving this we had already done in chapter number 7. You should be able to do all these questions. And getting the value of a, b and c. A I am getting minus 1, b is getting 1 upon 2 and c is equal to 1 upon 2. And substituting the values after integrating, I am getting this as 1 upon 2 log k square x minus 1 x plus 1 upon x square. This log k, that is a constant of integration. Now this is your answer when we were supposed to find the general solution. Now when we are given that we have y is equal to 0 when x is equal to 2, so we have to substitute here the value of y and the value of x. And I am getting here log of 3k square upon 4 is equal to 0, which will give me 3k square. This 0 can be written as log 1. So I can write 3k square upon 4 is equal to 1 and getting the value of k square as 4 upon 3, which we'll be finally substituting in this equation number 3, so that our answer will having all the values without any kind of constant. So after substituting as k square is 4 upon 3, I'm getting this as the final answer. So whenever it is given that at y is equal to this and x is equal to 2, means there we are not supposed to find the general solution. We have to find the general solution, but after that we have to substitute those values and we have to find the particular solution of that question. And your next question, 15. Then this is your question, find the equation of a curve. This is your 15th question. Passing through the point 0, 0 and whose differential equation is y dash, means dy by dx is equal to e to the power x sin x. Passing through 0, 0. Again we will be finding the particular solution, means x is equal to 0 and y is equal to 0. So here you will be doing the same kind of normal integration, taking all the values of x toward the right hand side and y towards the left hand side, and after integration here we will be doing uh, by parts. See this? ILATE. So what will be your first function? That will be sin x, and the second function will be e to the power of x. So after integrating, I am getting here the value as y is equal to e to the power x sin x minus cos x upon 2 plus c. This is a whole is integration. This I am not going to explain it here because you already know and you should know. Now in this equation number 2, we will be putting e to the power x, means x is equal to 0 and y is equal to 0. See this, putting all the values. I am getting the value of c, e to the power 0 is 1. C I am getting here as 1 upon 2. Right? Now this c, the value of c we will be putting in equation number 2 so that we can get the final answer. See here, substituting 1 upon 2 and taking just LCM. After LCM, I am getting 2y minus 1 is equal to e to the power x sin x minus cos x. So whenever it is given like this also, they might not be giving you the direct question that x is equal to this when y is equal to this. So you have to understand the question that this 0, 0 means you have to find the particular solution of the given differential equation. And your question number 18. At any point xy of a curve, the slope of the tangent is twice the slope of the line segment drawing the point of contact to the point this. Find the equation of the curve given that it passes through minus 1 and 2. So we are given that the tangent is twice. The tangent is twice the slope of the line segment drawing the point of contact to the point minus 4 and minus 3. Let the point of contact, we'll say x and y. We should know the formula for the slope, that is y2 minus y1 upon x2 minus x1, which will give me the slope as y plus 3 upon x plus 4. So dy by dx will be is equal to 2 times this slope because it is given twice the slope. So here the equation becomes dy by dx is equal to 2 times y plus 3 upon x plus 4. Again doing the same thing. Taking all the y terms on the one side and all the x terms on other side and integrating. After integrating, I am getting here the value as y plus 3 is equal to c into x plus 4 to the power 2. This is a general solution. But what they are asking us? When it passes through minus 1 and 2, means the value of x is minus 2 and y is 1. See this? Substituting this value, y as 1 and x is minus 2. getting C as 1 and putting the value of C here in equation number 1, I am getting this is the required equation of the curve. So this was your exercise 9.4, and in the next class we'll be doing the solution of the homogeneous differential equations. Means when you are unable to separate two variables, then what to be done. So I'm ending it over here. We'll be doing it in the next class.